next question before us is question number 48. The value of sum of complex numbers sine of 2k pi by 11 minus I cos 2k pi by 11 where k runs from 1 to 10 is, first option it is -1, second option is 0, option C is minus I, and the option D is I. Let us try to simplify. What is the given question? Sigma sine 2k pi by 11 I cos 2k pi by 11 k running from 1 to 10. With a simple effort, with a simple idea, we'll be able to get it simplified. Let me write this as sigma k is equal to 1 to 10 minus I into cos 2k pi by 11 minus I sin 2k pi by 11. So that I may be able to use the Euler's definition, that is cos theta minus I sin theta is nothing but e power minus I theta. E power minus I theta. You imagine minus I into, is it minus or plus? Sin 2k pi by 11 minus I cos 2k pi by 11. Okay. Minus I into this is okay. Minus I into minus I is minus I square 1. This is also okay. Okay, this is equal to sigma k is equal to 1 to 10 minus I into e power minus 2k pi by 11, isn't it? Of course, by making use of Euler's definition, that is e power I theta is nothing but cos theta plus I sin theta, and thereby e power minus I theta is cos theta minus I sin theta, isn't it? This is again minus I into k is equal to 1 to 10 z power k, where z is equal to e power minus 2 pi by 11. Let me write e power minus 2 pi by 11 whole power k. I can write it so that it is minus I into, come on, z plus z square plus z cube and so on up to z power 10. Again, the number inside the brackets is again a sum of a GP containing 10 terms, z square, z cube, etc., etc. And you can be in a position to estimate it by making use the formula for the sum to n terms of a GP. How can you do that? This is equal to minus I into, come on, let you simplify, z into z power 10 minus 1 by z minus 1. Z into z power 10 minus 1 by z minus 1. So that this is equal to minus I into z power 10 is z power 11 minus z by z minus 1. Here, what is z power 11? Z power 11 is e power minus 2 pi into I. Z power 11 will be cancelled. What is e power minus 2 pi I? Cos of minus 2 pi plus I sin of minus 2 pi. Cos of minus 2 pi is cos 2 pi. Cos 2 pi is cos 360. Cos 360 is 1. Sin 360 is 0. Hence, z power 11 is 1. Hence, this is equal to minus I into 1 minus z by z minus 1. What is 1 minus z by z minus 1? It is minus 1. Minus 1 into minus I is I. Hence, the answer is I. The fourth option, that is option D, is the right option. The next question before us is question number 49. If z lies on the circle z mod z minus 2i is equal to 2 root 2, then the value of argument of z minus 2 by z plus 2 is equal to first option pi by 3, second option pi by 4, third option pi by 6, and the fourth option, that is option D, is pi by 2. Let us see. We should first of all understand the position of z. It lies on the circle mod z minus 2i is equal to 2 root 2. Mod z minus 2i is equal to 2 root 2. And we are asked about the value of argument of z minus 2 by z plus 2. If p is the complex number z, then we want to have the angle between AP and BP, where A is the point 20 and B is the point minus 20. What I mean to say is, by looking at the question, what type of thinking you must be able to fix in your mind are z minus 2 by z plus 2. Z minus 2 by z plus 2. If you take 2 as the point A0, minus 2 as point minus 20B, then angle between AP and BP, that is angle APB, you are required. That is first of all. What does the point A and B? Lying on x-axis. How are they connected with the problem? Let us see first of all. What is the position of the point Z? It lies on the circle mod z minus 2i is equal to 2 root 2. If you take z as x plus iy minus 2i is equal to 2 root 2. If you square on both the sides, you'll be having x square plus y minus 2 whole square is equal to 8. It is just nothing but the circle with center 0, 2 and radius 2 root 2, isn't it? Not followed. Mod z minus 2i. We believe that mod z minus z bar is equal to R is a circle with center Z0 and radius R. Therefore, this is a circle with center 2i is nothing but the point 0, 2 and radius 2 root 2. Let us first of all observe the circle. The center lies on y-axis, that is at the point 0, 2. How can we believe that? In the place of Z0, we are having 2i. 2i is the point 0, 2. It definitely lies on y-axis. Well, it's very simple to believe that this equation is nothing but x square plus y minus 2 whole square is equal to 2 root 2 is the radius, it is 2. Where does it cut x-axis? Take y is equal to 0. X square plus 4 is equal to 8. So x square is equal to 4. So x is equal to plus or minus 2. Yes. Let me name these 2 points A 20, B minus 20. And this is of course the point C, center of the circle. It's very simple to notice that AB is subtend a right angle at C. How? How and why? What is the slope of AC? Minus 2 by 2 is minus 1. What is the slope of BC? Minus 2 by minus 2 is 1. Hence, we are sure to say that this angle is pi by 2. Pi by 2. Now, let P, say PZ be any point on the circle. On the circle. Look here, as this is pi by 2, angle subtended by the chord AB at P automatically will be half of this, that is pi by 4, isn't it? From the earlier properties of circles and segments, it's very easy to notice that the angle subtended by a segment at the center is just double that angle subtended by the same segment line segment in the other segment of the circle. Therefore, as this is pi by 2, this must be pi by 4. From the figure itself, you see that angle APB is pi by 4. Angle APB is pi by 4. Exactly half of this. 45 degrees or simply pi by 4. What is angle APB? Is just nothing but argument of z minus 2 by z plus 2. Z minus 2 by z plus 2 is pi by 4. As you have to construct the angle and in the anti-clockwise direction, AP, PB, like this. Therefore, it is z minus 2 by z plus 2. Answer is pi by 4. It is a minimum knowledge of the diagram is just enough to trace the answer for this question. Yes, that's all. Therefore, the answer is pi by 4. Option B is, of course, the right option. We shall now look at the next question, that is question number 50. If z is a complex number such that the equation mod z minus a square plus mod z minus 2a is equal to 3 always represents an ellipse, then the range of a belongs to R plus a is. The range of the positive real number a is. He is asking about the range of small a. Where does it lie? The first option, that is option A, is open interval 1 to root 2. Second option is closed interval 1 to root 3. Third option is open interval minus 3 to 1. And the fourth option is open interval 0 to 3. First of all, what is z here? Complex number, which is always supposed to lie on an ellipse. And equation of that ellipse is, of course, mod z minus a square plus mod z minus 2a is equal to 3. And he is asking about the range of a, where a is a positive real number. In the data itself, from the data itself, we believe, we take it for granted that a is a positive real number. Well, to make a proper attack on the question, we may have to recollect our knowledge from locus in coordinate geometry. Let me recall a beautiful concept from the chapter locus. That is, if capital A and capital B are two fixed points and capital P is a moving point such that PA plus PB is equal to K, then what is the locus of P? It is a famous problem in the chapter. Here you see, if K is greater than AB, then it is an ellipse. If K is equal to AB, then P lies on the segment AB. And if K is less than AB, such a point P never exists at all. The set of all points or the domain of P is an empty set. Yes. Here you see, if PA plus PB is equal to K and K is greater than AB, then it is an ellipse. How can you believe that? Let us consider the general form, the general graph of an ellipse. Let it be some x square by a square plus y square by b square is equal to 1. Let the two foci be, say, A and B. Let capital P be any point on the ellipse. Then we all know that the sum of the focal distances PA plus PB is always 2A. That is the length of the major axis. But you see, let us recall the formula for the foci. This is minus A is 0 and this is A is 0, and the distance between them is 2A. A is 0 and minus A is 0. 2A is of course less than 2A, isn't it? Therefore, PA plus PB is 2A is greater than AB. That must happen. then only it forms an ellipse. Otherwise, not. Absolutely not. Therefore, he is saying that this equation always represents an ellipse. Let me name this P capital A, P capital B. PA plus PB is 3. What does it mean? The distance between A square and A is less than 3. That is, this distance AB is less than PA plus BB, isn't it? Therefore, mod A square minus 2A less than 3. That should happen. This is the crucial and key point here to catch. Unless or otherwise, it is not possible at all to trace the domain of A. Yes, we are able to have this step simply because he has said that this equation represents an ellipse. That is why mod A square minus 2A is less than 3. Of course, we can proceed in our usual way of solving inequalities to get the nature of A, small a of course. Yes, let us follow that. A square minus 2A is less than 3 means minus 3 is less than A square minus 2A is less than 3. As mod x is less than 3, it is supposed, it is believed that x lies between minus A and plus U. That is minus 3 and plus 3. Well, from this we have two inequalities, namely minus 3 is less than A square minus 2A and A square minus 2A is less than 3. From this, A square minus 2A plus 3 is greater than 0. A square minus 2A plus 3 is A square minus 2A plus 3 greater than 0, and here A square minus 2A minus 3 is less than 0. Both of them should happen. You observe this quadratic expression. What is the discriminant here? B square minus 4AC is negative. Therefore, this is lifelong positive. A square minus 2A plus 3. Okay, na? Okay. Well, so we have to solve this. A square minus 2A minus 3 is less than 0. What does it mean? Can you have the factors here? Of course, why not? A minus 3 into A plus 1 less than 0. Isn't it? Well, this says that A belongs to minus 1 to 3. Open interval minus 1 to 3. But you see, in the question itself, in the data itself, he has said that A is positive. Therefore, A must be positive, and from this A can be any real number, and from this A belongs to minus 1 to 3. Intersection of all these three statements is A must belong to open interval 0 to 3. A must belong to open interval 0 to 3. Therefore, what is the right option? Option D is the right option. Fourth option is the correct option. Right. We shall now deal with the next question, that is question number 51. Omega is a non-zero, non-real complex cube root of unity, and A and B are real numbers. If omega and omega square are roots of 1 by A plus x plus 1 by B plus x is equal to 3 by x, then A and B are the roots of. A and B are the roots of. He is asking us. As usual and as all of us know, that omega is a complex cube root of unity. It's non-real, of course, complex cube root of unity. And 1 by A plus x plus 1 by B plus x is equal to 3 by x. That is the given equation. And according to the data, that equation has the roots omega and omega square, the complex cube roots of unity. Then A and B are the roots of. He has given us as usual 4 options. The option A is 3x square minus 6x plus 2 is equal to 0. Option B is 6x square minus 3x plus 2 is equal to 0. Option C is 2x square minus 3x plus 6 is equal to 0. And option D is 6x square minus 2x plus 3 is equal to 0. Let us now examine, let us now explore the answer. What is the given equation first of all? 1 by A plus x plus 1 by B plus x is equal to 3 by x, correct? Implies b plus x plus a plus x by a plus x into b plus x is equal to 3 by x. That is, I have taken just the LCM. Let me now cross multiply. 3 into a plus x into b plus x. X square plus a plus b into x plus ab is equal to x into x plus x, 2x plus a plus b. Now, here it is 3x square, here it is 2x square. If you bring that 2x square this side, you will be going to have x square. Let us now think of x terms. Here 3x into a plus b, here x into a plus b. If it comes this side, it becomes 2 into a plus b into x. Now, constant terms. Here it is 3ab, that's all, plus 3ab is equal to 0. If you want, you can verify it once again. X square terms. Here, these are 3. There, it is 2x square. Bring it here, it becomes x square. Now, the terms containing x. Here it is 3x into a plus b. There it is x into a plus b. Bring it here, you will have 2x into a plus b. Now, the constant terms. Here it is 3ab. There is no constant term. As a result, 3ab only remains here. Has the roots omega and omega square. Has the roots as omega and omega square. Who told us? It has given us. He has given us. Isn't it? Omega and omega square are the roots of. Well then, what is the sum of the roots? Implies sum of the roots, that is omega plus omega square is equal to, what is the sum of the roots of this quadratic equation? Minus a minus b by a. But you see, omega plus omega square is minus 1, as we know from the properties of cube roots of unity. 1 plus omega square is 0, rather omega plus omega square is minus 1. Minus 1 is equal to minus 2 into a plus b. So, you can note that a plus b is equal to 1 by 2. A plus b is equal to 1 by 2. A plus b is equal to 1 by 2. Well and good. A plus b is 1 by 2. Again, some of the roots you could have used. What about the product of the roots? Also, omega into omega square. What is the product of the roots? C by a. That is 3ab by 1. What is omega into omega square? Omega cube. What is omega cube? 1. So 1 is equal to 3ab. Therefore, AB is equal to 1 by 3. AB is equal to 1 by 3. Then, what is the question actually? A and B are the roots of. What does it mean? He is asking us to have the equation whose roots are A and B. So what is required actually? You are supposed to have equation whose roots are A and B. Therefore, required equation is, come on, A and B are the roots. What is the equation? X square minus x into a plus b plus ab is equal to 0. From the knowledge of quadratic equations. Well done. What about a plus b? What about a plus b? We know that it is half. What is ab? It is 1 by 3. Well done. Multiply it with 6. What happens? Is equal to 0. 6x square minus 3x plus 2 is equal to 0. is of course the required answer. Where does it lie? It is available in the option B. Right answer is 6x square minus 3x plus 2 is equal to 0. The next question before us is question number 52. If z is a complex number such that mod z minus 1 is equal to 1, then argument of 1 by z minus 1 by 2 may be. First option is pi by 6, second option is minus pi by 2, third option is pi by 4, and the fourth option is minus pi by 4. How can we estimate it? It's very simple. One of the most crucial information given in the problem, the hypothesis itself, is mod z minus 1 is equal to 1. He has given us. And we are asked to find argument of 1 by z minus 1 by 2. First of all, let us understand z. What is the nature of z? Mod z minus 1 is 1, is equal to 1. Okay, so z minus 1 is a complex number of modulus 1. Let me try to express z minus 1 in mod amplitude form. How can we write? Z minus 1, mod z minus 1 is 1. He has said, so that I can write z minus 1 is equal to cos theta plus I sin theta. Because its modulus is 1. From this we have z is equal to 1 plus cos theta plus I sin theta. Again you can have 1 plus cos theta as 2 cos square theta by 2 plus I into 2 sin theta by 2 cos theta by 2. From this you can have 2 cos theta by 2 as a common factor. If you get 2 cos theta by 2 as a common factor, what will be going to remain inside the brackets? Cos theta by 2 plus I sin theta by 2. What is that? What is that? Cos theta by 2 plus I sin theta by 2. And I would like to write it as cis theta by 2 with our usual symbolism in complex numbers. Cis theta by 2. I mean cos theta by 2 plus I sin theta by 2. This is of course z. Okay, what is 1 by z? 1 by z is therefore 1 by 2 cos theta by 2 into cis theta by 2. Well, my dear, you cannot do anything with 2 cos theta by 2. But of course, if you send cos cis theta by 2 to the numerator, it becomes, come on, what does it become? Cis minus theta by 2 by 2 cos theta by 2. Well, let us simplify. One by z is equal to, what is cis minus theta by 2? Cos theta by 2 minus I sin theta by 2 by 2 cos theta by 2. Cos theta by 2 by 2 cos theta by 2 is half minus I by 2 into tan theta by 2. This is all 1 by z is equal to. Bring that half also here. What are you going to have? 1 by z minus 1 by 2 is equal to minus I into half tan theta by 2. What can you observe? What do you observe? 1 by z minus half is purely imaginary, isn't it? No question of real part here. Of course, if you think of 1 by z, there might be some real part, of course. But you see, we are speaking of 1 by z minus 1 by 2, but not of 1 by z. Therefore, 1 by z minus 1 by 2 is equal to minus half into half tan theta by 2 is purely real. Sorry, is purely imaginary. Is purely imaginary. And if a particular complex number is purely imaginary, then we say that its argument is either plus pi by 2 or minus pi by 2. As it is minus half, minus I into something, etc. We say that argument of 1 by z minus 1 by 2 is of course minus pi by 2. Is it available? Exactly. It is available among the options. Option B is the right option. Therefore, what is the right answer? Minus pi by 2 is the right answer, and option B is the right option for this question. The crucial item here is, by imagining z minus 1 as is theta, that is cos theta plus sin theta, thereby step by step, every step will be at our feet. Yes. Thereby the answer is argument of 1 by z minus 1 by 2 is minus pi by 2. Option B. Let us look towards the immediate question. Is 53. A lot of big information has been given here. Let us follow it very carefully. Theta belongs to closed interval 0 to 2 pi. Theta is an angle which is non-negative, less than 2 pi. And Z1, Z2, Z3 are three complex numbers such that they are collinear. A beautiful concept. They are collinear. And 1 plus mod sin theta into Z1 plus mod cos theta minus 1 into Z2 minus root 2 into Z3 is equal to 0. If at least one of the complex numbers Z1, Z2, Z3 is non-zero, then the number of possible values of theta is the number of possible values of theta, so that the given condition is satisfied, that you have to collect, that you have to know. Well, beautiful question. It is a conceptual question. Yes, there are very little items to be calculated here. Concept is very important here. Well, what is it giving? Z1, Z2, Z3 are three complex numbers such that they are collinear points on the orgone plane. I know that every complex number can be represented as a point on the orgone plane. The three complex numbers Z1, Z2, Z3 of the present problem are collinear points. Okay, that is the actual concept which is to be used in this problem. How do you recognize that three points, say three complex numbers represent collinear points? Suppose Z1, Z2, Z3 are three collinear points such that AZ1 plus BZ2 plus CZ3 is equal to 0. Then what should happen? A plus B plus C must be 0. A plus B plus C must be 0. Beautiful concept. And it can even verify, it can easily be drawn, that conclusion can easily be drawn, because Z1, Z2, Z3 are collinear, and at least one of those complex numbers is non-zero. Let it be some Z3, the non-zero complex number. We can easily have CZ3 is equal to minus AZ1, or AZ1 plus BZ2 is equal to minus CZ3, and AZ1 plus BZ2 by minus C is nothing but Z3. So Z3 can be, as they are collinear, it divides the Z1 and Z2 in particular ratio, and in the place of minus we have A plus B, so that A plus B minus C is equal, A plus B plus C is equal to 0. A plus B plus C is equal to 0. In a nutshell, to say, in brief, to have three complex numbers Z1, Z2, Z3 are collinear, and AZ1 plus BZ2 plus CZ3 is equal to 0 is before you, then you can easily use that A plus B plus C is equal to 0. That is, of course, the strong weapon in our hands. That is the strong weapon in our hands to achieve the answer for this question. Well, let us turn our head towards the given condition. What is the condition? 1 plus mod sin theta into Z1 plus mod cos theta minus 1 into Z2 minus root 2 into Z3. Root 2 into Z3 is equal to 0. In the data itself, we are given that Z1, Z2 and Z3 are collinear, and as we have just discussed, we could have had a beautiful relation, say AZ1 plus BZ2 plus CZ3 is equal to 0, with A is equal to 1 plus mod sin theta, B is equal to mod cos theta minus 1 and C is equal to minus root 2. What can you use? A plus B plus C is equal to 0. That is 1 plus mod sin theta plus mod cos theta minus 1 minus root 2 is equal to 0. We are able to use this because Z1, Z2, Z3 are collinear. They are collinear. Well, what is going to happen? Let us observe. Mod sin theta plus mod cos theta is equal to root 2. And it can happen when and only when mod sin theta is equal to 1 by root 2, mod cos theta is equal to 1 by root 2. And it can be traced when and only when theta belongs to either pi by 4 or 3 pi by 4 or 5 pi by 4 or 7 pi by 4. It is an easy matter, of course, to recollect that theta belongs to this collection. How many possible values of theta are able to be observed here? 4 possible values are able to be observed here. So what is the answer for the question? 4. He has asked us the number of possible values of theta. How many possible values of theta are there? 4 possible values of theta are there. What are they? Pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. Well, my dear, we are able to arrive at this conclusion only because you are able to use the condition A plus B plus C is equal to 0 as and when Z1, Z2, Z3 are collinear and A Z1 plus B Z2 plus C Z3 is equal to 0 is given. Yes, that is why we say that this question is conceptual. This thinking is also conceptual. Yes, the answer is 4. The 4 values are like this: pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4 only.